Well, hello and a very good morning, a very good afternoon, and a very good evening based on the time in which you'll be watching this video. I hope every one of you is doing well, doing fine, along with members of your family. And I'm hoping that you all are also keeping yourself productive, a bit productive, and also enjoying the time in this lockdown. I hope that the previous video lecture was clear to you all. If you did have any doubts, please comment them in the comment section so that I can reach out to you via a different video or making a different video so as to clear and explain all the doubts which you all have. Let us just move on with the remaining parts of the chapter in which we'll be doing the plateaus and the plains and also dealing with the exogenic forces. So let us just move to the pen and paper copy so that it is easier for you all to understand and I'm able to explain it better to you all. Let us just move to the copy. In the previous video lecture, we were talking about the endogenic forces. Endogenic forces, as we understood, were the forces or are the forces which act from beneath the Earth's surface. And the endogenic forces are responsible for the creation of mountains, as you saw, and also of many other different types of landforms. Now, when we talk of endogenic forces, we also have to talk about the exogenic forces. What are the exogenic forces actually? Exogenic forces are those forces which are acting on the surface of the earth. Some of the most common exogenic forces is wind, water, you have glaciers. These are the most common exogenic forces which you have: wind, water, glacier. These are also called erosional forces. As you all know, erosion is removal of the top layer of the soil. So these exogenic forces are also the erosional forces. After the endogenic forces have created the mountains and the other related landforms, it is upon these erosional or these exogenic forces so as to form other types of landforms. When we are talking of those exogenic forces, what actually happens is, over a period of thousands and millions of years, running water, wind, glaciers, they keep on eating away into the mountainous areas. They keep on eating away into the mountainous areas. They keep on rubbing against the rocks. They keep on rubbing against the mountainous rocks, and gradually they are able to eat away those rocks, chip away a bit of rocks, and slowly the height of the mountains keep on decreasing. As the height of the mountains keep on decreasing, the cliffs of the mountain, as you can see over here, the cliffs or the peaks of the mountain become rounded, and the height keeps on decreasing. You have the Aravallis, which you all know as the old fold mountains. So the Aravallis are not it is said that the Aravallis once upon a time were as high or even higher than the Himalayas, but over millions of years, due to the erosional forces, wind, water, glaciers, because of these forces, the height of the Aravallis kept on decreasing. And similarly over here also, as you can see, the mountainous tops get rounded, the mountain slopes, they become rounded first, and then there is a gradual decrease in height. As the height keeps on decreasing, what actually happens is mountains give rise to plateaus. As the height of the mountain, suppose this area gets eroded up till this point, it becomes a flat land. As you can see, if the entire mountainous area above this entire area, this area, as it gets eroded due to these erosional or agents of erosion, what actually happens after that is that this area gets transformed into a plateau. So this is one way of the formation of a plateau. Also, at times, when the as you all know that mountains are formed when there is the one type of mountain, fold mountains. You all know it is formed when there is extensive folding. So when this folding occurs, when this folding is happening, when this folding occurs when this folding is occurring, there are different types of rocks which are getting folded. And you all know that metamorphic rocks are nothing but igneous rocks or sedimentary rocks which have been compressed under a lot of heat and pressure. So at times when we have the folding, or when the folding process is taking place, the rocks get transformed into metamorphic rocks. Metamorphic rocks are hard. Suppose this there is a mountainous area. Suppose this was a mountainous area, and these are the regions of metamorphic rocks inside the mountainous area. Metamorphic and igneous rocks. I am writing M for metamorphic, I for igneous, again M for metamorphic. And let these areas be made up of sedimentary rocks of the mountain. Now, you all know that sedimentary rocks are very loose in they are very loosely binded, and sedimentary rocks are soft, they are not that hard, and sedimentary rocks can easily weather off or can be easily eroded, whereas metamorphic rocks, igneous rocks, these are very hard rocks. Now you can very well imagine when erosion takes place, what will be happening is, first there will be a reduction of this cliff, and gradually all the sedimentary rocks will be eroded away, and what will be remaining is only these metamorphic and the igneous and metamorphic areas of the, so you will have a landform like this. So these are nothing but residual rocks or the residual mountains. Residual mountains are left behind when mountains are made up of different types of rocks, and when we have the harder parts of the rocks, do not get that easily eroded, and the harder part of the mountain does not get easily eroded, and the softer parts of the mountains made up of the sedimentary rocks, they get eroded, and you get a surface like this. The remaining area gets converted into a plain land. The remaining areas, these areas, they get converted into plain land, and in between this plain land you have these residual mountains which are left behind. The Parasnath mountain range is an example, Parasnath mountain is an example of the residual mountain which we have around us. Now we were talking about this area. Now when we have this kind of a structure left, we get a plateau. So this is an plateau which we are getting after erosional activities are taking place, and after we have got this plateau, and again subsequently as the erosion keeps on taking place, the plateau also gets eroded away, and at the end what we are left with is a plain land with few places where the rocks were hard. Suppose these were the place where the rocks were hard, so these could not get eroded, but generally what we have got over here is a plain land. So I guess you all understand how over time huge mountainous regions or huge mountains and mountain ranges, they get converted to plateaus, and gradually those mountains get converted and those plateaus get converted to the plain lands. Now you must have heard of something called a geosync line, or if you have not heard, just let me tell you. When this, suppose this is one plate, tectonic plate A, this is a C over here, and here is another tectonic plate B which is traveling upwards towards plate A. As B starts moving towards plate A, the C starts getting narrowed. B moves over here, again B moves over here, next B moves over here. You can see that the area of the C is getting narrowed. As this area of the C starts getting narrowed, what is actually happening is that the sea floor is going, or the sea floor is there is a depression in the sea floor. You can understand this. Why? Because when, suppose this was the sea floor, here was A, here was B was coming from this side, here was A. As B was approaching, it was keeping on pushing into this sea floor, and the sea floor was deepening, and the sea floor was keeping on deepening. Over here, as you can see, as this tectonic plate B keeps on moving towards A, this sea floor over here will keep on deepening. This thing will keep on deepening, and the sea will start getting narrower. When this keeps on deepening, what you get over here is a geosync line. And when there is that final thrust or push of B, and when B hits into A, what happens is that this geosync line, the geosync, you can see over here, this area is having three three distinctive places. One is this place, this is one margin, this is another margin, and this is this area. So let me term these as number 1, number 2, and this one as the number 3rd area. So as B keeps on moving towards A, and when B finally crashes onto A, when this B is finally crashing onto A, when this plate B is finally crashing onto A, what actually happens is that this margin, you can understand that this margin is 0.1, this margin is 0.2, and this is the number 3rd area. So this first margin and the second margin, they get elevated into mountain ranges, and this middle area, this depression, cannot rise that high because this was a depression at first. These were elevated lands from the start. So this depression area gets converted into a plateau. This is how you get an intermontane plateau. Most of the intermontane plateaus are formed when there is formation of mountains due to the crashing of one, or due to the collision of one tectonic plate on another tectonic plate. Let me just explain it once again. As B, suppose there was a C over here, and we have the tectonic plate A, tectonic plate B. As tectonic plate B starts moving towards tectonic plate A, what happens is that this area of the sea starts getting narrow, and the sea floor keeps on deepening, forming a geosync line. Sync line is the sync line, you all know, mountain has an anticline and a sync line. Sync line is the area where the sync line is that part when or where there is a depression. This is the sync line area. So we find a geosync line over here. Geosync line is a geographically formed sync line. So this geosync line keeps on deepening as B starts moving towards A. As B will be starting moving towards A, the sea over here will start narrowing, and this geosync line will be deepening. And when B finally hits A, what actually happens is that this margin of A gets raised as a mountain. A margin of B raises up as a mountain, and this geosync line forms a plateau. This is how the Tibetan Plateau was formed. And not only Tibetan Plateau, most of the plateaus which are intermontane plateau. What are intermontane plateaus? Intermontane plateaus are those kinds of plateaus which are found, or those plateaus which are found between two mountain ranges. So here I have A mountain range, here I have B mountain range, and in between I have the plateau. So this kind of inter means in between, montane means mountain. So here we have an intermontane plateau. Tibetan Plateau is an intermontane plateau. Example of another intermontane plateau is an Anatolian Plateau. Now at times what may happen is that suppose this was a plain land. This was a plain land, and this area of the plain, due to endogenic forces, it either moves up or it goes down. If this area goes down, what happens to this area? If this area was, let me just name it as X and this area as Y. If X goes down, Y gets turned into a plateau, and if goes up, X becomes the plateau. X goes down, and if it goes below the sea level, this area will be filled with the seawater, and Y becomes a plateau land. Similar is the case of our Deccan Plateau. When we talk of the Deccan Plateau, when we are talking of the Deccan Plateau, you all know that this area, the peninsular India area, you all know that here we have the Western Ghats, here we have the Eastern Ghats. The Western Ghats were formed after this area, this land over here, which is now the sea. previously here was land, and this land area subsided, went down into the sea, and this area was raised up. So we got the Western Ghats that way. Now there is another important thing which you have to keep in mind. When I am talking of the Western Ghats, this area was once a very active volcanic area. Now the volcanoes were located of our peninsular India. The volcanoes were located towards the western side, and the magma was made up of basic magma. You have to know that there are two kinds of magma: basic magma and acidic magma. When we talk of the acidic magma, whenever acidic magma tries to come out of the surface, there is a huge explosion and a volcanic cone is formed. But whenever there is a basic magma and it finds a crack on the earth, it does not explode. Rather, it keeps on flowing gently towards the slope of the land. And as it keeps on moving, you can see the point from where it is originating, that area will be, and as the lava or the magma keeps on flowing, it starts solidifying. Where the point from where the magma was coming out, that area will be higher, and as the lava will be flowing and moving further, the lava flow will keep on decreasing and the slope will also be low. So we will get a landform of this shape. Here again we get a plateau. So this area is made up of volcanic rocks, and we have a plateau over here. This plateau was formed because there were volcanoes of basic magma, and as the basic magma kept on flowing from the west towards the east, the slope of the land also became from the west towards the east. So you all will be studying later, but it is good to keep in mind that the Deccan Plateau of India or the peninsular India slopes from the west towards the east. That is why most of the rivers which are originating in this peninsular area, they flow from the western side to the eastern side, because the slope of the land is towards the east, because the volcanoes were located on the western side of this area. Now let us come to another topic, or let us just do the plain lands. Now when we talk of the plain lands, what actually happens is, this area, suppose, or let me just make a new one. Now when we are talking of plains can be formed by endogenic forces and also by the exogenic forces. Endogenic forces, how do they form the plains? Well, endogenic forces, they form the plains by, suppose there is a piece of land and this was submerged under the sea. This is the sea over here, and this is the shelf. This is one part of the crust. This is the ocean. This is right now the oceanic floor. Due to some, that was an extra over here. So due to some reason, or due to some endogenic forces, what happens is, this floor area, this sea floor area may come onto the surface, and surface as in this area may get raised and it goes above the sea level, and this becomes land area, and this becomes a part of, now if suppose this area goes up, now this goes up to this height, and there are mountains and plateaus going up. So this area becomes plain land area. This becomes a plain. It was nothing but this kind of a plain is formed. Why? Nothing but when the oceanic floor is raised due to the endogenic forces, we get a plain over here. Now there are other kinds of plains also. There are depositional plains, erosional plains. What are actually these depositional plains? Depositional plains are very easy to understand. Whenever a river is coming down from a mountainous area, it is carrying along with it eroded materials, and those eroded materials, as it moves from the mountainous areas into the plain land, these eroded materials cannot the river cannot carry those eroded materials. Why? Because when it is flowing down a mountainous area, the river is having higher amount of speed because of the slope of the land. As it enters the plain land, the speed decreases very suddenly and it is unable to carry that huge amount of load. That is why it deposits most of its loads at the foothill of the mountain or mountain range, or where the plain land starts. This kind of a plain land is called, this is a Piedmont alluvial plain. Piedmont means nothing but it is located at the, Pied means leg or the foot. Pied means it relates to the leg or the foot. So this kind of a plain is formed at the foot of a mountain. That is why it is the Piedmont plain. Next, we also have other alluvial plains. Next, we have the flood plains. What actually happens is, as the river is flowing, it due to occasional flooding, as it flows onto the banks, it deposits its alluvium or the sediments or the eroded materials. So this is forming a plain land area on both the sides of the river. This is a flood plain, and as the river enters or is about to enter the sea, over here the river fans out or makes deltas. So these deltas also form plains. We have the deltaic plains over here. So a river forms three kinds of plains in its course. Over here we have the Piedmont plain at the foot of the mountains. In the middle course we have the alluvial or the flood plains. Alluvial or the flood plains. And near the, where at the mouth of the river where it is about to enter the sea, we have the deltaic plains. Now these are different kinds of plains formed by the rivers. Now plains are also formed by glaciers. How do glaciers form plains? It is easy to understand. This is a mountain and a glacial block is coming down. As this glacial block comes down, it scoops up parts of the mountain, or it scoops up huge amount of rocks from the mountain surface, and it carries it downwards. But as the glacier is moving down, it also keeps on melting, and at the foot of the glacier or at the foot of the mountain where the glacier has melted, it keeps on depositing those these rocks which it had scooped from the surface of the mountain in its upper course. So these get deposited at the foot of the mountains. These deposits are called moraines. So gradually these moraines fill up the entire area, forming a plain land. This is a glacial plain or a moraine plain. Next, we also have lacustrine plains. It is nothing but when we have similar to this kind of a plain, when rivers, they bring a lot of the plains which are formed when the river, which brings a lot of alluvial deposits those alluvium on both the sides of the river, we get lacustrine plains. The lowest plains are nothing but loess, LOESS, is nothing but fine dust. So these dust is carried by the wind, and it is mostly formed in the desert areas or where the soil particle is very loose. So the lowest plain can be formed, just give me a minute. So these lowest plains are formed when the winds carry the dust deposits or the dust from the desert areas and deposit it on some area or on land, and it keeps on depositing, making the surface plain, or keeps on depositing the loose soil materials on the land, making it a plain. This is the lowest plain. And coastal plains, well, coastal plains are nothing but suppose this is a mountainous area. This is, you can understand, this is our peninsular India, and here we have the coastal plains. How were these coastal plains formed? These coastal formation of these coastal plains. So these are mountains over here. We have the Western Ghats, we have the Eastern Ghats, when rivers were flowing from these areas into the ocean, they were bringing along with it lots of sand and silt. Those sand and silt deposits started forming these plains. There are more number of rivers in the eastern side than in the western side. That is why the eastern coastal plain is much wider, because of the more amount of deposits of these many rivers, and less rivers in the western side. That is why the in the western side, the western coastal plains are much narrower than the eastern coastal plains, because of the lesser number of rivers, and that is why the lesser number of, or the lesser amount of alluvial deposits on these sites. Now I hope the plains and the plateaus, also the exogenic forces which are giving rise to these kinds of landforms, are clear to you, to all of you. If you do have any doubts, please post them in the comments, and if there are any problems, if there are any problems in the previous chapters, if there are any other queries, other doubts, please do post them in the comment section, so that I can reach out to you all with another video, or with a video in which I'll be trying to explain all your doubts. Well then, this part was, or this chapter, the landforms of the earth, I hope it was clear to all of you. If you did have any problem, as I just mentioned, please do not feel shy. Please also go through the entire video, not only this video. If there are other videos available, not if, there are other videos available in YouTube. So please go through such videos and try to learn a bit about these plain formation and the plateau formation, and also about the exogenic and the endogenic forces. If you have problems, and if you do want some explanation on different types or different parts of this chapter, or also of different chapters of any other concepts in geography, please comment them in the comment section, so that I can make videos on them. Please stay safe, be safe, and also keep enjoying this lockdown. Thank you.